The cloakroom lost every ticket, so the coats go back at random. I already know tonight's lucky count. Here's the claim. Hand the coats back blind, and on average, exactly one guest leaves in the right coat. Grow the party as much as you like, and the average refuses to move. That sounds wrong, so let us test the smallest party that can tangle. 3 guests make the smallest tangle, and 3 coats can only come back in 6 different orders, so watch every possible night, all 6 of them. Some nights, nobody wins. One night, everyone does. Now add the winners. 6 matches across 6 nights. The average is exactly 1, just as promised. But brute force dies fast. 5 coats already come back in 120 ways, and a real crowd is hopeless. So ask a smaller question. Follow one single guest. The pile was shuffled blind, so the coat that lands in her hands is equally likely to be any coat on the rack. 1 chance in 3 at our little party. That is her entire story. Now the step that feels forbidden. The guests are tangled together, but averages do not care. Take the 6 nights we already checked and count the check marks a new way, guest by guest instead of night by night. Every guest column holds 2 check marks out of 6, 1/3 per guest. 3 columns of 1/3 make 1. The same marks, the same total, read down the columns. Averages add, tangled or not. Now every guest carries an average of 1 ticket out of n. Add 1 such share for every guest, n shares of 1 over n. The n cancels against itself. The crowd size never had a vote. 5 guests or 5 million. On average, exactly 1 coat goes home right. One warning before you bet on it. An average of 1 is not a promise about tonight. At a 5-coat party, more than 1/3 of all nights end with nobody in the right coat, and exactly 4 winners is impossible. If 4 coats are right, the 5th is forced right too. The 1 is a long-run average. When a random total looks hopeless to track, split it into 1 small average per guest and add. The tangle never gets a vote.